We're going to be taking a look at video games in education, and specifically how those video games might be able to develop cognitive skills such as spatial intelligence. Over the years, there have been numerous studies looking at the auxiliary effects or benefits of playing video games, and what they're finding is that there are quite a few areas where the playing of video games actually develops skills, both cognitive and physical. Studies have shown that playing video games regularly can increase and improve problem solving and critical thinking, increase creativity, increase attention and concentration, improve spatial and hand-eye coordination, improved vision, and increased speed, both mentally and physically. In fact, a German research study from 2013 studied how computer games like Mario 64 affect the brains of players. They asked 23 adults with the average age of 25 to play Super Mario 64 for 30 minutes a day for 2 months. They also had a control group who played no games at all. What they found was amazing. After scanning the brains of the players in the control group using an MRI machine, they found the gamers had a noticeable increase in gray matter in the right hippocampus, right prefrontal cortex, and cerebellum. These are the areas responsible for memory, strategy, fine motor skills, and spatial navigation. In the control group, they didn't find that same growth. That means that playing video games actually grows the brain. Video games have also been shown to aid social-emotional learning as well. Looking more closely at visual spatial intelligence, it's the intelligence that has to do with the capabilities to perceive the visual world precisely and to make changes or modifications even without stimuli. Or in layman's terms, it's be able to see the 3D environment, 3D objects in your mind's eye and be able to manipulate them. According to Howard Gardner, the multiple intelligences theory, visual and spatial intelligence is being able to create and interpret visual images and think in 3 dimensions. Spatial intelligence includes being able to read maps and translate that to the real-world environment. We're navigating through 3D environments. It all goes back to being able to visualize and see 3D environments and objects in one's mind's eye and be able to manipulate them. To give an example, whenever you go on a trip, most families have one person that tends to be the packer who puts all the luggage into the trunk of the car. And that person tends to be the one with the better spatial intelligence because they can visualize how those pieces will fit into the trunk and how to maximize the space and make it all work. Kind of like playing a real-life game of Tetris. And in most families, that happens to be the male. In addition to being one of the lowest scoring of all the cognitive skills amongst humans, it's also the cognitive skill where there is the largest gender gap. Numerous studies have shown that over a course of various spatial intelligence testing, men tend to have a much higher aptitude from early on in life than women. Helping erase this gender gap between men and women with spatial intelligence is of keen interest to researchers because spatial intelligence is a key cognitive skill for careers such as engineering. And if we are trying to prepare our young females for potential careers in engineering, having video games geared towards females could be one potential way that we could boost and erase that gender gap in spatial intelligence. Research into the effects of video game play and spatial intelligence go way back to the 1980s when the first 3D video games started emerging. Gagnon published a paper in 1985 looking at the differences between men and women's performances in spatial intelligence tests between the video game Targ and the video game Battlezone. There was no improvement in either group after playing the 2D game Targ for an extended period of time. But what was interesting is the results from playing Battlezone. Battlezone was the very first video game to emulate a 3D environment and put players into that environment and have to be able to navigate through it. Test results indicated that women improved greatly in their spatial intelligence and scored on the post-test almost as well as men did, and men did not improve at all. This was the first indication that video games can improve the spatial intelligence of players and that the potential for erasing the gender gap is possible. In a similar study in 2007, Feng conducted a test where Men and women both participated in 10 hours of gameplay in the games Balance, which is a non-action game where you guide a ball around a maze, and Medal of Honor, Pacific Assault, which is a high-intensity first-person shooter game. The results showed all participants improved in their testing with Medal of Honor, but did not improve with Balance. And in addition, the women benefited far greater than the men. This indicated that an intense high-action game was better at improving spatial intelligence scores than a non-action game, and that women can benefit greater than men because of their lower starting point as far as their spatial intelligence abilities. A 2008 study by Cherney had participants testing on the 2D game Tetris and the 3D game Ants Extreme Racing. And it showed that the 3D game of Ants was better at improving spatial intelligence scores, especially with women. In 1994, Subramaniam did a study where children were tested after training for 45-minute sessions on the game Marble Madness, a 3D game, versus Conjecture, which is a word game. Their results indicate that strong dynamic spatial skills enhance the mastery of a video game, whereas video game practice improves relatively weak dynamic spatial skills. So what does it all mean? Video games can in fact improve spatial intelligence skills. 3D games are more effective than 2D games. High-intensity action games are more effective than non-action games. Players with low or weak spatial intelligence abilities at the outset can and will benefit more greatly, and there seems to be a plateau where more video game training will not increase spatial intelligence noticeably. This leads to the conclusion that the 3D environment and the high-intensity action of first-person shooter games mean they are the best at promoting and improving spatial intelligence. The problem is that women tend to not play or enjoy first-person shooter games and favor the types of games that do not necessarily promote or enhance spatial intelligence. So where do we go from here if we want to develop video games that appeal to women and also promote and enhance spatial abilities? A study is currently underway at the Montana State University of Bozeman under a National Science Foundation grant looking at the possibility of creating games in Minecraft that will develop and promote spatial intelligence and games that appeal more to females. For the first iteration of the study, 2 games were created in Minecraft that simulated problems usually presented on spatial intelligence tests when given on paper. A mental rotation test, where players look at an object and see how it's been rotated in 3D space, and then apply that same rotation to a secondary object. The other game was a mental orientation test, where players look at a 2D representation of a structure on the wall and then recreate it in 3D. The third game for training players on spatial intelligence was a more story-based and true to real-world type of simulation game where players had to race to make food deliveries while a ticking clock counted their time. Players were given a 2D map to use to navigate through the 3D environment. At the time, research indicated that immersive, true-to-life training in video games is much more effective than the drill and kill type of training, so this provided a different and preferred scenario to the other 2 games. Also, adding the ticking clock created an intensity that the 2 other games didn't have. The results on this round of testing were inconclusive as to whether any of the 3 games provided improvement with spatial intelligence skills of the participants, and this may have been due to several reasons. One concern was that the players did not receive enough training time. In the following round of testing a year later, the 3 games were combined into one with an immersive storyline added to it. In order to save the village, the player must retrieve the magic sword and armor to slay the giant beast. The player must navigate through 5 different mazes. Each one, at the end, would be a puzzle for them to solve. And those puzzles are enhanced versions of the mental rotation and orientation test from the previous round of testing. Once the students solved the puzzles, they will earn a glyph, one for each of the puzzles in that maze. When all 4 glyphs are collected from that maze, the player receives one of the magic items needed to defeat the monster. Once the items were collected, they were sent back to the village where they would take on the giant monster and try and save the village from ruin. The data from these tests are still being analyzed. The hope is that with continued research, a formula will be found for creating the perfect video games that will enhance spatial intelligence that are effective for both males and females.